Hi folks, this is tutorial 11, which is a continuation of tutorial 10, but as a standalone module. I mentioned that tutorials 10 through 15 are solving the same problem, involve solving the same problem, but using different strategies. Uh, uh, Tutorial 10 was called the obvious strategy. So here I'm going to propose a different one, strategy 1, which pertains to the same problem that we had before. We have a structure here, clamped at this end, roller on that side, and there is an internal hinge here. And what I did in tutorial 10, I made a single line here and a single line there. And now what I'm gonna do is I'm gonna make two lines, one here, one there, left one, right one, or the middle one and the right one, and then create a connector between these two because of the internal hinge, and create a connector between these two, which is gonna be welded as if essentially they're pretty much it's not there. There's no hinge there, okay? So the problem is coming out of Hibbeler's structure analysis book, and based on the data that's given here, assuming that the cross-section is circular radius 2.486, I'm going to get a deflection. Should be getting deflection of 4.58 at the point B. Okay. Now, so here's my strategy: left line, middle line, right line. There's going to be concentrated force here and internal hinge there. This was done in tutorial 10 as a single line and putting this force in the middle of it, but here I'm going to do it more complicated. And this is going to be a weld type connector, and this one is going to be a hinge or a joint or a cylindrical. Now, what I did in 10, I showed you that whether I use hinge, joint, or cylindrical, I'll get the same answer. So I'm not going to repeat that. I will only use the hinge. Okay, so make sure that when you create these three lines, do not join them because we want to have duplicate nodes at where they come together so that we can essentially tie them together through the connectors. And because I want duplicate nodes here, when we mesh these separately, we make sure that this checkbox is off so that it doesn't merge two nodes which are within a certain distance of each other. So this is off. That means that there's going to be a node here and a different node on this side, okay, at the same location, okay? And I will only do, as I said, I will only do hinge. Now, because I'm not going to be using, join or cylindrical that was done in 10, I don't need this, but hinge, I don't need this, but hinge requires a local coordinate system because it tells you the axis but which is hinging. So I do have to create a local coordinate system here, and well, it does not, of course. So anyway, hinge does, and we're going to create a local coordinate system. All right, and okay, so these we're just going to use the hinge, which is this is coming out of Fidelis's FEA link, and this is analytical calculation using principle of mutual work to show you what the deflection at the internal hinge should be, roughly 4.58 downward. Okay, let's go ahead and do that. Because I'm gonna be I don't need to join anything. That being the case, I can do it in part design or I can do it in generative shape design. This time I'm going to do it in part design. It really doesn't matter. I'm going to create three lines, a line, point, and direction. Point I'm going to make 0, 0, 0. Direction is going to be direction Y, and the length is 12 feet. All right. The next line is going to be again point and direction from this point, direction Y, another 12 feet. Okay, and the last one is going to be 15, point and direction, this point, direction Y, and 15. Okay. Now we're going to apply material to this thing. The material is linear elastic, Young's modulus 29,000 KSI, and uh, Poisson ratio 0.3. So let me go ahead and make this thing tools. I'll make one. I'll call it steel. This is September 17, 2024. Okay, it's created right there. I'm going to apply it to this part. It work. Try it now. Yep. And now we input the values. So structural, abacus multiphysics, mechanical, elasticity, elastic, 29,000 KSI, 29,000 KSI. Okay, Poisson ratio 0.3. And say okay. Good. That's pretty much it. Oh, while we are at it, let's create our coordinate system. Actually, coordinate system. Let me go back to here. Let me create my coordinate system because I'm going to need it. And it doesn't matter where you put it, but I prefer to put it exactly where the hinge is. So I'm going to put it, this is where the hinge is going to be, right there. And X is in this direction of the hinge opening. Good. So now we're going to go and mesh these things. So structural models creation, it's an empty FEM. All right, click on the mesh, beam mesh, 1 foot. So I do this one. Notice that this checkbox is off so that later on it will not merge things, mesh. The first one doesn't matter, but the second one does, because if this is not off, then within the tolerance that you have specified in here, these are going to get merged, but I don't want them to be merged, so that's why this is off, mesh. And last one over here. And once again, 1 foot, there's going to be 15 elements there, so that's fine, because this is 12 feet, 12 feet, 15 feet. And now cross section, so we go to properties, create a profile. It's a circle, and the radius is 2.486 inches. All right, and yeah, so now we create sections. Beam section. I can do them simultaneously, all three of them, because they have the same cross section. But make sure you choose the profile 1, and then we say okay. All right, that's pretty much it. So yeah, remember when I did in tutorial 10, I created a group at this node because I uh, have to put the load on that group. But anyway, right now, let's not forget to do the connections. Connections. Let's start with this one. Okay, so I click on the connections tab, scroll to the right. There is connections, and first of all, the type. If I'm doing this one on the left, which is uh, at the between exactly. Let me see exactly this location. Okay. So I need to say, first of all, it's going to be a support is going to be, let me hide this. The support is going to be this point. Second support is going to be the side of the other side, but the other side is in hiding, so I can go there and select it from there. Okay, let's go back here. And I don't want it to be beam, I want it to be weld. Right there. Notice that weld doesn't have the option, doesn't ask you to select local system. So there it is. Okay. So that takes care of this connection, welded connection. Well, Let's do another one for the other fellow, which is between these two. So another connection. So the second one is, I could have given this thing meaningful name. So let me call this thing uh, Hinge. The other one is the weld, which I'm not going to rename it, just leave it the way it is. So for the first support, I'm going to select the end. Let me hide this. Can I select this point? Yeah, right there, this vertex. And for the second one is going to be that point. This is the middle one that's in hiding right now. Okay. And very good. And the type is hinge. Okay. And this is the direction of the opening of the hinge, which is correct. You say, okay. So I created my connections right there. Where are they? Right. This is the hinge. The other one was weld. That's okay. Let me update these things, make sure that there are no issues. That's okay. We'll take care of that. Now pretty much done here. So let's go ahead to the scenario creation, structural scenario creation. We select our model, FEA model, select the procedure, and it's going to be static perturbation, which is a linear analysis basically. Okay, so now for the boundary conditions, one end is clamp, this end is clamp, this end is on the roller, so fixed displacements, you select that point. It does not move in X, does not move in Z, it can move up and down the Y-axis. It's free to rotate about the X-axis, but the Y-axis and Z-axis rotations are fixed. Now let's do the forces. So we go to loads, force. Now, before I had to create a group to put it there, but now I can select at that vertex, if I can get the vertex, okay, vertex, because it's welded to the other one, there is no ambiguity. It's just going to go down, minus 8 kilo-pound. Okay. Notice that because they're welded, whatever vertex I put it on, it really doesn't matter. They're tied together basically. And we have a concentrated moment at this end. So let's go ahead and apply a torque at this point. Negative clockwise direction, negative 30,000 pound foot. Yeah. Okay. Hopefully we haven't forgotten anything. And let's go ahead and first of all check it. Model and scenario check. Remember there was a warning. Okay. Oh, I forgot when I created my hinge, I forgot to select the axis. That's what happened. That's what it's saying. It says missing local axis system. Okay, no problem. So let's go pick it. That's what it's saying. So let's go back to uh, this connection that we created, this hinge connection, right there. Notice that the axis system was not picked. Axis system is the one that I created. Remember, if I said if you don't have one, then you have to go and create it, but I already did it at the initial stages. And now we're going to do a model and scenario check. No problem. And I'm not going to do the middle one. I'm just going to run it because I feel good about it. I think it's going to run. And notice that you can change that hinge to cylindrical and join, etc. As I did in tutorial 1, you're going to get the same answer. I better get 4.58 inches down. And this was strategy number 1. So in the next 3, I will keep varying these things, doing it different, using things which are not connectors. These are other things that we're going to do that. Let's see now. Better come out with 4.58. Oh, displacement. 4.58. Good. So that takes care of tutorial 11.